This is the lesson video for 4.2 and 4.3. You're going to start writing equations in some of the different forms we've already learned and some new forms. We've learned standard form before, we've seen it. We do know that the A, the B, and the C are just numbers that get put into the equation. But they have to be not decimals and not fractions in standard form. We aren't going to write as many equations in standard form in this chapter, except some of the word problems may come up like that. Slope-intercept form we started working with in the last few days in 4.1. Slope-intercept form is really handy if you have or can find two different things, and you need them both. We need the slope, and that's what the M stands for, the slope, or what we called rate of change. If you have something about feet per second, miles per hour, one of those numbers that has two units in comparison, that's your rate. And then you need your B, and we called that the beginning amount, the amount before everything starts adding on to it. The other thing it's called when you do your graphs is it's called your y-intercept. If we have those two pieces of information or we can easily find them, then I'd write my equation in slope-intercept form. The one that we haven't worked with yet is called point-slope form, and I'm going to try to convince you that this is the one that can do so much good work for us, and that even if we needed another form of the equation for our final answer, it's a really good one to start from, because all we have to be able to find or already have in order to write an equation for a graph with this form is we have to know the slope or the rate of change still. That's why it's called point slope, because we do have to know that, how the equation is moving. In other words, what is our rate of change? 10 miles per hour, $6 per hour, 5 feet per second. And then the other thing is we need any data point about it. And we're going to call that point x1, y1. Any point on the line or that actually meets that relationship. If we have those two things, then we can go up to this form of the equation and actually put it all together. So let's try some of these together. You guys do better when we actually kind of put it all together. So on the graph, which is the first one, the first thing I see is I have a point. They identified a specific point that this graph goes through as -1, 2. It's not on the y-axis, so it's not a y-intercept, so it can't be my b value. And from here, I think I can count some slope. I think this is a rise of 1, run of 2. So on my graph, I see a rise to run. Definitely a positive slope. It's going up 1, to the right 2, so my slope is 1/2. So when I look back at the three forms of the equation, standard form, well, I don't even know what to put in there. Slope-intercept would be great because I have a slope, but I don't have the y-intercept. I can estimate it, but I don't have it. When I look at the third form, point-slope, I do have a point and a slope. So we're going to try to use that form to write our equation. So let's start with the fact the basic equation says y minus, and then it leaves an open spot. And it leaves the slope as an open spot, so I'm going to put an underline. And then in the parentheses, it says x minus, and it leaves an open spot. And what it's telling me is I need to take this x1 point and put it where x1 goes in our formula, so my x1 is -1. I need to take my y1 and put it where y goes in the formula, y1, which is right there. And I need to bring the slope over. Then I'm just going to clean it up just the littlest bit. Y minus 2 equals 1/2. X minus -1 is a keep change, x plus 1. I can stop there if they don't tell me what form of the equation to put it in, or if they say point slope is okay. If they ask me for slope-intercept, I'm going to have to move that around a little. And we'll try an example like that in a second. All right, the next one down, you won't be able to see the forms at the top of my screen, but you have them at the top of your page. They want the equation for a line through this ordered pair, and that sounds to me like they're giving me a point, and then a slope of 5, and they're giving me the slope. So again, I'm going to use point slope formula because that's what I have. So point slope formula says regular y minus, and then whatever the y from your ordered pair is, your y1, in our case, -4. Point slope formula, look at the set formula up above, and then it says put in your slope next, right here. So my slope is 5. Then x minus, then I have to go back over and get my x1, which is 2. The only things we clean up after that, if we're allowed to leave the equation that way, is any minuses. So this is really y plus 4 is 5 times the quantity x minus 2. And that's my final equation for that one, because it describes the line with a slope of 5 through the ordered pair 2, -4, so I could graph it or someone else would know what I was looking for. All right, the next one. Oh, I see a data table. A data table means that in order to get my rate of change or slope, I'm going to have to do a little bit of work. I see my data table increasing by 3, which is my rise. And then when I come over to my x's, from -1 up to 2, count on your fingers, that's also an increase of 3 for my run. So therefore my slope is rise 3, run 3. My slope is 1. I also have 2 different ordered pairs, so I'm just going to grab either one of them so that I have a point. And my point I'm going to grab, like I said, I'm going to grab 2, 6. You could also grab -1, 3. And when I go to write the equation to describe this, I'm going to use point slope form because I have a point and the slope. Remember, point slope form looks like this. This is a good form to write on your note card so that you also have that. But the 3 things I have to do are the y. So the only things that stay behind in the equation are the generic y and x that leave us places on the graph to go. So y minus, and there's my y coordinate, 6 in my point. My slope is 1. And then x minus, and I have to come back over to my x coordinate 2. I would probably leave the 1 in there for now, but you could take that 1 out because it's a 1 x minus 2 whether I distribute or not. So you're going to get a handout today, and it's a small handout. And the reason you're going to get it and get some tape so that you can get it taped to your note card and don't write all over it is that this tells you steps that you could take depending on which form of the equation you're asked to write. Writing equations, you could use point slope, you could use slope intercept. You really could even get standard form out of this if you had to. And it kind of gives you some steps to go through and shows you how you might plug things in and when to stop depending on the form that they ask you for. So you stop after the first 2 steps if point slope's the form they asked for in the directions. You keep going through steps 3, 4, and 5 then if the form that they asked you was slope intercept. None of yours are going to ask you for standard form tonight, so we're going to leave that one alone. Okay, now let's go try to use that graphic. They asked us for slope intercept form. Slope intercept form we know is the form y equals mx plus b. It is not always the easiest form to find, so what we want to do is find simpler ways to do it. So starting with the first equation, currently it's in point slope form. And they want us to move it into slope intercept form. So my goal then is to have it look like this y equals mx plus b equation before I'm done. So 2 steps to doing that. Distribute. And on one side we have distribution to be done so that we can start to work it out of this form. So 2 is my distributor. It has to multiply by x, so 2x. 2 is my distributor and multiplies by 4 to get 8. The other side is y minus 3. It's getting closer to that y equals mx plus b equation, but in y equals mx plus b, the y is alone. So I need to add 3 on both sides here so that I can get the y alone. So I'm going to leave a step behind. We may need to add or subtract to get the y alone. So now we've got y equals 2x plus 11. So this equation went from point slope to slope intercept that would be ready to graph or ready to work with if I needed to use it. So the directions are what you want to watch tonight to see what form they're asking you for, but you might want to start in the point slope form all the time and move it around. So I'm going to do that right now. The directions still say that my goal is to get it in slope intercept form by the time I'm done. So my goal is a y equals mx plus b equation by the time I'm done. But where I can actually start this one is a little simpler. I see a point, and they gave me a slope. And if you use that graphic that I gave you, it suggests that instead of trying to write this in y equals mx plus b form right away, because I don't know the beginning or y-intercept number, but I do have enough to write it in point slope form first. So I'm going to start in point slope form and then move it into slope intercept. All right, so in point slope form, it's going to be y minus, and I have to go to the y coordinate of my point, equals, then my slope, x minus, then I've got to go grab the x coordinate from my ordered pair. And now I'm going to move it into slope intercept form. And your directions on that little sheet I gave you to tape to your note card are going to help a lot. So I'm going to distribute that -1/2 because there's no parentheses in slope intercept form, so I'm going to have to work to get rid of those. So I have -1/2 x plus, because it's a -1/2 times 4, 2. And then I'm going to need one more step, and I'm going to move my goal out of the way. Hopefully yours wasn't in the way at the time. Put it back under here, right? So I'm one step away from having it in y equals mx plus b form. That was the goal. Is I've got to move this -3 so that y is alone. Plus 5. All right, let's try this. And again, we're on the page where it said we need these to be in slope intercept form by the time we're done. So try this one out. Try this one first in point slope, okay, because they gave us a point and the slope. Then I want you to pause the video, try to get it into slope intercept form, and see what you can do. So remember, our goal is slope intercept form. But we might start in point slope. Pause the video, come back once you think you have something to check. If you're back, you started in point slope form by starting this as y minus the y coordinate from my ordered pair, slope of -4, x minus the x coordinate. I'm going to clean that up and move it around, so you'd have y minus 3. Distribute -4x. Now, this subtracted negative was really positive, so when we multiply -4 by 2, we get that. And I'm going to add 3 on both sides so that I get the y alone, because that's the form we want. We're going to have y equals -4x minus 5. Ready to graph or ready to talk about the slope and the y-intercept. And finally, your final challenge, and this one is on the flow chart. Okay, you could start from 2 points. It says if all they give you is 2 points, you may have to identify the points and actually find the slope before we can write point slope form. So that's what's happening here. They like the line through those 2 points. So I think I'm going to start by just finding slope, because both my forms of the equation that we've been using need the slope. So slowly we want to go through our y2 minus y1 calculation and our x2 minus our x1 calculation. And as I do that, I'm going to get -3 divided by -6, and when you simplify that, we get a slope of 1/2. So now I have a slope and I have 2 points. So I can choose whichever point I want to use. I'm just going to take the first one. I take the one with the fewer negative signs. And I started in point slope form. Y minus the y. You may be catching on that if it's y minus a negative, we could just go y plus right away, equals a slope of 1/2 x minus the x. The only problem is that's point slope and it requested slope intercept. So now if you follow your directions on your visual aid there, we need to distribute those. I'm also going to clean this side up a little bit. 1/2 x minus, we can either say 5/2 or 2.5, whichever you'd like. And finally, if I need y equals mx plus b form, then I really need to be ready to move this around. I would leave my slope as a fraction. I think it's more helpful that way. Negative 2.5 minus 2 is negative 4.5. You want to pause the video, go back to parts you didn't understand, make sure that you've got that template taped onto your note card so that you can use those as steps for any kind of question that they ask you about writing equations of line.